Hello everyone, Anirudh here. I am currently a third year undergraduate student in the Department of Computer Science and Engineering and Tolerance 4-year BTech course, studying in Indian Institute of Technology, Kharagpur. And I'm from Chile. For those of you who have failed your geography exams or your social studies or any part of social studies for the matter, Chennai is in the right? This is part 2 of your differential equations exercise. And in part 1, I think I have covered up till exercise 9.4, right? This question. So today, we'll be dealing with 9.5, 9.6 and miscellaneous exercises. And before we jump into the exercise, right? In exercise 9.5, what we're going to deal with is homogeneous differential equations. What exactly does that mean? A homogeneous equation is basically something of this form, right? Where if you have some function f, say f of x comma y, right, a bivariate function, and we are not dealing with multivariate complex functions, we're just dealing with a bivariate, right? If you have this be some random function, right, and say you replace x by lambda x and y by lambda y, right? Basically multiplying both these variables with scalar, right? If this a new function is exactly equal to f of x comma y, then you call f to be a homogeneous function. Right? That is basically its definition over here, right? If you can see this, that's basically what they've given. If you replace x and y by lambda x and lambda y, for any non-zero constant lambda, we get this to be the answer, something like this. And you see that yeah, right? F of lambda x comma 1 second. This is lambda power n f of x comma y for some lambda belonging to z, right? So if this condition holds, that f of lambda x comma lambda y equals lambda power n f of x y for some n which is an integer, then you can say that this function f is homogeneous, right? Now, what does that mean for a differential equation? For a differential equation, your y dash, right, equals some function f of x over y, always, because the differential of a function is also a function of its own regard, right? And so this y dash is said to be homogeneous if this y dash is said to be homogeneous if this is going to be homogeneous, right? And if this is homogeneous, then you can basically represent it of the type g of y by x into some x power something, right? So basically this form, right? This is basically what you mean by a function being homogeneous, right? So you have what exactly this differential is homogeneous mean, right? And now how do you solve it? It is by making the substitution y equals bx and proceeding further, right? You have this form y dash is equal to v plus x divided by dx, and from this you substitute and you get the value of whatever and right? That's how you solve a homogeneous differential equation, right? Again saying, I told you this before also, but you have to be very diligent in looking at these examples because there are many good questions over here and there are many points that people tend to overlook, and some different methodologies and some pretty good tricks are given in these examples, right? So do not skip them, right? Now we are going to deal with exercise 9.5. So for the first two questions, what you have to do is that you have to show that the differential equation is homogeneous and then solve it, right? How do you show that a differential equation is homogeneous? By using the properties I mentioned above, right? This f of lambda x comma lambda y is lambda power n f of x y. You have to show this for each and every differential equation, right? Now we have question number 1, right? You have x squared plus xy whole times dy equals x squared plus y squared times dx, right? First of all, you're in the standard form, your differential equation looks like dy by dx equals x squared plus y squared divided by x squared plus xy, right? First thing, right? Which means that if you basically show that this function is homogeneous, then you prove that the differential equation is homogeneous. How do you prove that this function is homogeneous? You basically bring it to the form of, which form? You basically bring it to these one of these two forms, right? X parent gy by x or y parent h of x by y, right? If any of these two forms get printed over here, I mean, excuse my computer terminology, but if any of these two forms is going to be the reduction of this function, then you basically have to prove that this is going to be homogeneous, right? And so what you basically do is you divide the whole thing by x squared. So basically it becomes 1 plus y by x the whole square divided by, you are dividing the whole thing by x squared, right? By x squared. This and this divided by x squared. So basically it's going to become 1 plus y by x the whole square divided by 1 plus y by x, right? Which is basically some function g of y by x, right? Since dy by dx is some function of y by x, that means that this is homogeneous. This is homogeneous. If I'm marking an h over here and round, it means that I have proved that it's homogeneous, right? Because of this, right? And how do you solve this? You make the substitution y equals vx, right? A note over here, if your function is of the form g of y by x, then you make the substitution y equals vx, right? If on the other hand is of the form h of x by y, then what you do is you make the substitution x equals by. All right. Just remember that it's a note for the future, note for some future sums. We're not going to use this over here. We are only going to use this. Make the substitution y equals vx. What we get is dy by dx is equal to b plus x dv by dx equals 1 plus b squared divided by 1 plus b, right? Because y equals bx, this says that y by x equals equal. So what we have is x dv by dx is this minus b, which is 1 minus b plus b squared minus b squared divided by 1 plus b, which is 1 minus b by 1 plus b, right? Therefore, dx by x equals dv by 1 minus b times 1 plus b, right? And you basically solve this by some kind of a partial fraction method, which basically says that since it's 1 minus b over here, you take 1 minus outside. So it's minus of 1 plus b times dv divided by v minus 1, right? And this is v minus 1 plus 2. So this is equal to minus of 1 plus 2 by v minus 1 dv, right? And so what you have is just integrating on both sides. You have ln mod x equals minus of b plus 2 ln mod b minus 4 plus c, right? Which means that ln mod x equals minus y by x minus 2 ln mod y by x minus 1 plus c. Basically taking this to the other side, we have ln mod y minus x by x the whole squared plus ln mod x equals minus y by x plus c, right? And since you have this plus mod x over here, that means that one of these mod x's get cancelled. And so you basically can remove this off, put a minus over here, basically have ln of, this is basically y minus x the whole squared divided by mod x equals c e power minus y by x, right? And that is the solution to the first question. Or you can also basically write this in a better form as y minus x the whole square equals cx times e power minus y by x, right? Since c is an arbitrary constant, you can also multiply this by 2 and 2c still remains c because you don't care what the value of this c is because it's an arbitrary constant, it changes, right? That's question number 1. Question number 2. Question number 2 states y dash equals x plus y divided by x. Pretty simple to prove that this is homogeneous because it's 1 plus y by x, which is basically a function g of y by x, right? So this is homogeneous. Pretty easy to prove, right? And it's also very simple to imagine the solution of this equation, because what you're basically going to do is substitute y equals vx, then you will have v plus x dv by dx equals 1 plus v, because v is equal to y by x, right? And dy by dx equals v plus x dv by dx as given in the NCERT over here. Where is it? Yeah, as given in NCERT over here, as well as me having proved it in the previous question, right? I'm not going to write that proof further. And so this v and this v get cancelled. You're basically left with dv equals dx by x, or integrating further, you get v, which is y by x, v equals y by x equals ln mod x plus c, or basically x equals c e power y by x as the solution, right? Or if you want to, represent it in terms of y equals, then what you can do is basically instead of doing this, make y equals x ln mod x plus cx, right? Also another valid form, right? Nobody is going to begrudge you if you write in any of these forms because they're full. That's the answer to your second question. Question number 3 is x minus y into dy minus x plus y into dx is 0, right? First of all, we can simplify this equation by stating that x minus y dy equals x plus y into dx, right? No brainer. And then bring it to standard form. Dy by dx equals y dash equals x plus y divided by x minus y, right? This is standard form. From here, pretty easy to prove that it's homogeneous. Divide the whole thing, divide the numerator and the denominator by x. You get 1 plus y by x divided by 1 minus y by x equals, this is basically y dash equals. And since this is of this form, this can be represented as a function g of y by x, right? And so it's homogeneous. Now, since you have proved it's homogeneous, make the substitution y equals vx, and then basically you will get it's v plus x times dv by dx equals 1 plus v by 1 minus v, right? Taking this v to the other side, this becomes minus v, and you're left with 1 plus v minus v plus v squared divided by 1 minus v to be your answer, right? And plus v minus v get cancelled. You are left with v square plus 1 divided by 1 minus v, right? And so you finally have dx by x equaling dv times 1 minus v divided by 1 plus v squared, right? Integrating on both sides, this basically gives you ln mod x equals this. You basically want to do this, you look at partial, right? No, not partial fraction. This you can just this you can split into. This basically, this is integral of dv by 1 plus v squared minus integral of v dv by 1 plus v squared, right? And this gives you tan inverse v, I'm directly substituting b over here, right? Tan inverse b minus, this gives you half of ln mod 1 plus b squared, right? 1 plus y squared by x squared. Now, since you have a ln mod x over here, we can basically simplify this, right? This is plus c, of course, right? Since you have a ln mod x over here and a ln half ln whatever over here, you can try to simplify this, right? So we basically have on one side tan inverse y by x plus c equaling ln of, wait, I'll just make this half ln. This is half ln of x squared, right? You can basically write this as, this is half ln of x squared, right? Because x squared, a ln of x squared is 2 ln x, no greater, right? So this I'm bringing it to the other side. So this is going to be added to this, which means that it is basically ln of x squared times 1 plus y squared by x squared, right? Which is equal to half ln of y squared plus x squared. Therefore, your solution is tan inverse y by x equals half ln of y squared plus x squared plus c, right? You may be confused as to why I'm writing this plus c on some other side every time I'm going to rewrite this equation. It's because this c is pretty much an arbitrary constant. It can occur anywhere, anyhow, any place, right? And I mean, anywhere, anyhow, any place as a plus. Right? You can't basically multiply the c here and say that it's going to be the same solution. That's wrong. But it can occur anywhere if it's a plus on the right side, on the left side, nobody cares, right? Because it's going to be an arbitrary constant. And minus c is also, right? This is the solution to your third question. This is the solution of question number, right? X squared minus y squared times dx plus 2xy dy equals 0, right? Again, bringing it to standard form, is dy by dx equals, this is y squared minus x squared divided by 2x squared, right? Because if you bring this to the other side, you get y squared minus x squared dx equaling 2xy dy, right? And then from here, you basically bring dx down, you bring this down, you get this form, right? This is the standard form. From this, easy to prove that it's homogeneous. You basically have y dash equals, this is what, you divide this by x squared, you divide this by x squared. And so you basically have this to be y by x, the whole square minus 1, divided by 2y by x, right? Which is some function g of y by x, which means that it is homogeneous, right? And so what you do is you basically make the substitution y equals bx. And so y dash is equal to b plus x dv by dx equaling b squared minus 1 by 2b, right? Bring this to the other side, you basically have minus of 1 plus b squared by 2b, right? Because this becomes minus 2b squared, and b squared minus 2b squared is basically minus b squared, right? And so finally, you have dx by x equals dv into 2b by, wait, this is a minus dv by 2b divided by 1 plus b squared, right? Therefore, you basically integrating on both sides, basically have ln mod x equals minus of ln mod 1 plus b squared plus c, right? Why is ln mod 1 plus b squared? Because if you take this as t, then dt is going to be equal to 0 plus 2b, which is 2b, which is there in the numerator, right? Wait, 0 plus 2b dt. So this is going to be 2b dt, which is the numerator, right? So this is basically dt by t, which is minus ln mod 1 plus v squared plus c. And if you substitute what is v, you basically have ln mod 1 plus y squared by x squared plus ln mod x equals c. And that is the solution of this differential. Right? Now, you can actually simplify this further, since you have two ln terms and adding ln terms is also easy. You can basically simplify this and say that this is basically x squared plus y squared by x equals e power c, right? But this is also a constant. This is again some other constant c, capital C, right? So you can write that this is basically this differential equation basically is x squared plus y squared equaling c times x, right? Which is the equation of a family of circles, right? I'll let you figure out what the characteristics of this family of circles is, but this is a family of circles, right? I'll give you a hint. It has two major properties that you have to figure out, right? It's just two major properties, and each of that is bound by the fact that you don't have a y term, you don't have a constant term in this equation. You basically have only the two square terms and this cx term, right? That is a hint which will give you the two properties of the family of circles that is described by this linear equation, differential equation. I'm not giving examples, right? Question number 5. This is x squared dy by dx equals x squared minus 2y squared plus xy, right? So we have this expression number 5. We completed till number 4, right? And for number 4, I said that you had two properties. This is the equation was x squared plus y squared equals cx. And I said that you have to figure out two properties, right? So I'm writing this down because I'll come to this later after I finish 9.5 and say what are the two properties that I wanted to figure out. But yeah. Question number 5. Right? X squared dy by dx equals x squared minus 2y squared plus xy. Right? First of all, bring it to standard form. This is basically y dash equaling 1 minus 2 into y by x the whole squared plus y by x, right? Which is a function of y by x. Perfectly, right? Therefore, it is homogeneous. No brainer. Now, again, the way you solve this is by taking the substitution y equals bx. And so you basically have v plus x dv by dx equals 1 minus 2v squared plus v, right? dv gets cancelled out. You basically have dv by 1 minus 2v squared equals dx by x, right? Here, this is 1 minus something, something into v square, right? So you can basically do this in two ways. Either take this as either take the variable root 2v as some other variable t and then do a substitution and proceed, or basically use your standard formula with some adjustment or some other method that you see fit, whatever, right? It's going to be one elementary step, right? What you're going to get is basically tan inverse of root 2v divided by root 2. Okay. Where is the tan inverse? I'm sorry. What is going to be is basically ln mod 1 minus root 2v divided by 1 plus root 2v, not wrong, right? This equals ln mod x plus c, right? And this will be, this is multiplied by 1 by 2 root 2, right? Because this, if this is 1 minus v squared, then you have half ln mod 1 plus v by 1 minus v. But since you have 2v over here, you'll have to divide it by root, right? So you basically have this being this is 1 by 2 root 2 ln mod 1 plus this is x plus root 2y divided by x minus root 2y equaling ln mod x plus c, right? And that is a solution to question number 5. Question number 6, right? X dy minus y dx equals square root of x squared plus y squared times dx, right? What do? First of all, bring the dx term to the other side, right? And then bring it to standard form. Y dash equals root over x squared plus y squared plus y divided by x. Because this is dx, x goes down, and whatever is the coefficient of dy goes down, right? Over here, pretty easy to see that this is also going to be homogeneous. Basically, divide this x over here, divide this x over here. We'll say that under root, it is 1 plus y by x the whole square plus y by x, which is a function of y by x. Therefore, homogeneous, right? And then make the substitution y equals vx as usual. So basically, v plus x dv by dx equals square root of 1 plus v squared plus v, right? dv cancels out. We basically get dv by root of 1 plus v squared equals dx divided by x. I hope everybody remembers the integration of this. Right? It was given, I think it was given in a special note under integral calculus, where this basically integrates to ln mod v plus root of 1 plus v squared equaling ln mod x, right? Therefore, we have removing the ln, basically raising it to power e. We have y by x plus root of 1 plus y by x the whole squared equals c times x, because e power c is also a constant c, and removing this x, taking this x common out, we have y plus square root of x squared plus y squared equaling cx squared, right? And that is, you can also write this form, no worries, but this is going to be much more simplified and much more easy to basically write out, right? That's question number 6. Question number 7. 7 basically states that x cos of y by x plus y sine of y by x. Wow, writing this is going to be a pain. Into y dx is equal to y sine y by x minus x cos of y by x times x dy, right? First off, divide this whole thing by x, by x squared, right? First off, you will notice that over here is basically this thing into it into y divided by x squared times dx. This is this thing into x divided by x squared times dy, right? I'll take LHS first, right? Because it's pretty big. I don't want to make a mistake somewhere. So I'll take LHS first, right? It's basically x cos of y by x minus y sine of y by x divided by x into y by x times dx, right? And over here you can see that this basically this x goes off, and here you get y by x, and you remove this x, right? This is equal to cos of y by x minus y by x sine of y by x whole times y by x dx. right? And RHS, again, since you're dividing it by x squared and you have an x outside, this x and 1x goes off. So basically I'm left with this whole thing inside. It's y sine of y by x minus x cos y by x dy, right? This divided by x, right? Simple to see that this is basically equal to y by x sine of y by x minus cos y by x whole times dy, right? And so you can basically see that this is also a function of y by x. This is also a function of y by x. So the whole equation becomes a function of y by x, right? Because the LHS and the RHS both are functions of y by x. Therefore, you can prove that the equation is homogeneous, right? Alright. Instead of doing it that way, I'll just make it more formal, right? So basically equating LHS equals RHS. You basically have, I'll just put a bit. This is I'll make it in a standard form, right? So that'll be easy for you and right? Dy by dx. So I'm basically making it to the RHS and bringing the RHS to LHS, LHS to RHS, making mirror images, right? So whatever is on the RHS as the coefficient of y is going to go down, right? So this is equal to cos of y by x minus y by x sine of y by x, right? So plus divided by y by x sine of y by x minus cos of y by x whole into y by x, right? Therefore, this is basically a function g of y by x. Therefore, the equation is homogeneous, right? Making the substitution y equals bx, thankfully, because I can't keep writing on y by x again and again, right? Making the substitution y equals bx, you basically have b plus x dv by dx equaling cos b plus b sine b divided by b sine b minus cos b whole times b, right? Bringing this b to the other side, this basically becomes minus 1 over here, right? There's the area we want it. So basically, this becomes a minus 1 into b, right? Therefore, if you just simplify this over here, what you're going to get is cos b plus b sine b minus b sine b plus cos b divided by b sine b minus cos b whole times b, right? And this b sine b and b sine b is going to cancel. They're basically going to be left with 2b cos b by b sine b minus cos b, right? Therefore, equating everything, you're going to be left with v sine v minus cos b divided by 2v cos b dv equaling dx divided by x, right? This is equal to ln mod x plus c. This is going to be equal to this. You'll have to separate out into, right? So basically, first the first term is going to be half of, wait, I just take this half outside. This is going to be half of tan b dv minus this is going to be 1 by b dv, right? Integral of both. This is equal to half of ln mod secant x plus c minus this ln mod b. Equally ln mod x plus c, right? Back substituting v as y by x, what we'll have is basically ln mod, this is secant of y by x divided by y by x. So basically, I can write this as x secant y by x divided by y equaling ln mod x plus c, right? Therefore, removing this ln, I'll just take this half on the other side, right? So removing this ln over here, you basically have x secant x by y divided by y equals x squared. It's cx squared, right? Since you have an x over here, one x goes off, and so you're basically left with secant of x by y is equal to cxy, right? Or you can basically say that xy cos of x by y is equal to, wait, what a minute, this term is funky. This is y by x, this is y by x, this is also y by x, right? Because secant is 1 by cos. Bring this cos to the other side becomes a c x by cos of y by x is 1. And bring the c to the other side, 1 by c is also another constant c. So basically, x by cos of y by x equals c, right? Any of these two forms are correct. Nobody, it does not matter what form you wish to actually provide in your answer script because it's going to be the same. That's question number 7 taken care of. Question number 8. This is x y dash minus y plus x sine of y by x equals 0, right? Divide this whole thing by x, divide by x, right? What you get is basically y dash minus y by x plus sine of y by x equals 0, right? Which in the standard form, it is basically y dash equals y by x minus sine of y by x, which is basically a function g of y by x. Therefore, it is homogeneous, right? And now, using the same old substitution y equals bx, this still becomes a bore after a point, but you have to persevere. What to do? Right? Basically, using this whole thing, you have b plus x times dv by dx equals b plus, again, b minus sine b. dv cancels out. You basically have dx by x equals dv by sine d and a minus, right? So you basically have ln mod x equals, this is basically cosecant b d, right? And the integration of cosecant b is ln mod cosecant b minus cot b, if I'm not wrong. And there's a minus, adding the integration constant. Therefore, we basically have cosecant of y by x minus cot y by x equaling c by x, right? Because this minus can go to the other side and this becomes ln of 1 by x, basically. If this constant goes to the other side, that becomes a ln of c by x, something of this sort. And so removing the ln on both sides, you have cosecant y by x minus cot y by x equals c by x, right? Really, screw things up a bit. Then what you can do is expand the formulas for cosecant and cot and basically represent this in terms of cos and sine, right? So basically you have 1 minus cos y by x divided by sine of y by x equaling c by x. Never mind that this is the formula for tan of y by 2x. Don't really care about that, right? This form is enough. This is your final answer, right? Or if you want to, sorry for that. If you want to, you can cross multiply this x over here and sine of y by x over here, and basically linearize this to form x times 1 minus cos of y by x equals c sine of y by x, right? But you don't really need to do this because that form is also substituted. This is the linear form. This same as this, both are the same, right? That's question number 8. Question number 9. Question number 9 says that y dx plus x ln y by x dy minus 2x dy. What you do again is the same old story, where you basically take this to the other side. You have y dx equals a dy times 2x minus x ln of y by x. And then basically you start writing it down as y dash is dy by dx equals y by x, right? You can take this x outside. So basically bring this x over here, that becomes y by x divided by 2 minus ln of y by x, right? Since this is a function g of y by x, that means that this is homogeneous, right? And so you basically do the same old substitution of y equals vx, and then v plus x dv by dx equals v divided by 2 minus ln v, right? Taking this to the other side, you have what? This is v ln v, v ln v minus v divided by 2 minus ln v, right? Because 2 into v is 2v and v minus 2v is minus v. So basically this is what you get. And so you basically have dx by x equaling dv into 2 minus ln v divided by v ln v minus v, right? This, what you can do here is basically separate 2 minus ln v as 1 minus ln v minus 1 whole times dv, right? Divided by v into ln v minus 1. Easiest way will be to do this and basically make this as dv by v times ln v minus 1 minus dv divided by v, right? Basically this is dv into 1 by v ln v minus 1, v ln v minus v minus dv times this divided by this whole thing, right? This and this get cancelled and you are left with dv by v, right? Therefore, on this side you have ln x equals, on this side this is basically, if you take this as t, then this is going to be dt, right? So this is basically ln mod ln v minus 1 ln of y by x minus 1 minus ln mod y by x, right? So basically, and then of course you have this, right? So basically what you have here, if you remove all the lns, is x equaling ln of y by x minus 1 divided by y by x whole into c, right? Since this is y by x over here, you can basically remove this by x, make it an into x, and so this x and this x gets cancelled out. So you are left with y equaling c times ln of y by x minus 1, or cy equals ln of y by x minus 1. That is, I mean, yeah, this is my answer, right? This was question number 9, right? We're almost at an end to the first part of the exercise. Last question. E power x by y dx. Okay, this is also again 40. It's 1 plus e power x plus y dx, x by y dx plus e power x by y into 1 minus x by y dy equaling 0, right? Notice that every place you have x by y over here, right? Therefore, if you basically rewrite this equation in standard form, this basically becomes, this is, make this an equal to, remove this equal to 0, this is a plus, this is a minus, right? Basically multiplying this by minus. Now over here, I can basically rewrite this as dy by dx equaling 1 plus e power x by y divided by e power x by y into x by y minus 1. This is a function h of x by y, therefore homogeneous. Since it's a function of x by y and not y by x, what we do is instead of dy by dx equaling this, we rewrite this to basically make dx by dy equaling the inverse of this equation, right? So basically it's e power x by y into x by y minus 1 divided by 1 plus e to the power x by y, right? Using the substitution x equals by, as I told you in the first question, right? When you notice that the equation is written in the form h of x by y, you basically do the substitution x equals by, right? And on the left hand side, you have dx by dy and not dy by dx. That is another important thing that you have to note, right? Because this on differentiation gives you dx by dy equals v plus y into dv by dy, right? Remember this. It's not dv by dx over here and it's not x over here. It's v plus y dv by dy. And on the left, it is dx by dy. So basically, v plus y dv by dy equals e power v into v minus 1 divided by 1 plus e power v. Bringing this v on the other side, you basically have v e power v minus e power v minus v minus v e power v. So basically this gets cancelled out, divided by 1 plus e power v. Therefore, we have dy by y equaling dv into 1 plus e power v into minus 1 divided by v plus e power v. Right? You can basically see that if this is t, then this whole thing is going to be dt. Because the differentiation of this, v is going to be 1 dv and e power v is going to be e power v dv. Right? This minus sign is going to be excess. So basically integrating on both sides, you have ln mod y equaling minus ln mod v plus e power v plus c of this, right? Which means that this is basically y into, I'm basically back substituting over here, right? Bringing this to the other side, you basically have a multiplication, right? Because ln a plus ln b is ln of ab, right? And multiplying and removing the lns over here, I'm skipping a step, right? What you have is y into x by y plus e power x by y equaling a constant c, because e power constant is also a constant, right? Therefore, this means that x plus y e power x by y is going to be constant. And that is the solution of it, right? Now we have 7 questions left, right? Question number 5. We have x plus y into dy plus x minus y into dx equaling 0 and the point 1, 1. Right? Again, you can basically see that this is homogeneous, because if you divide this whole thing by x, you'll get a 1 plus y by x and 1 minus y by x. And if you make a standard, you'll get a homogeneous polynomial or g of y by x. Right? If you want, I can show you how you get that. Right? It's like it's basically this way. If you don't want, just skip this step and move forward 30 seconds. This equals y minus x times dx, and then dy by dx becomes y dash equals y minus x by y plus x. Basically divide this by x, numerator and denominator. You have y by x minus 1 divided by y by x plus 1, which is a function g of y by x. right? So since you have this equation, right, make the substitution y equals dx over here. And so you will see that v plus x dv by dx equals this what? V minus 1 by v plus 1, right? Or take this on the other side. You basically have this is v minus 1 minus v square minus v divided by v plus 1, right? Therefore, this reduces down to dx by x equaling v plus 1 dv divided by 1 plus v square, right? Or more explicitly, ln mod x equaling this we have done earlier, I guess, right? This is minus tan inverse of y by x minus half ln mod 1 plus y squared by x squared, right? Or more simplistically, this is half ln mod x squared plus y squared. The mod is not necessary over here. Plus tan inverse of y by x. Since there's a constant over here, it's constant, right? Now, since we are given that this curve passes through the point 1, 1, basically substitute this over here, you get that it's half of half ln 2 plus tan inverse 1 is pi by 4, right? Equaling c. Therefore, you basically have the particular solution as half ln of x squared plus y squared plus tan inverse of y by x equals half ln 2 plus pi by 4. And that's the answer, right? I just write this properly. This pi is not some kind of an weird x or something. That's fine. All right. That's question number 1. Question number 12. This is x squared dy plus xy plus y squared dx equaling 0. Right. And again, the point 1, 1. Great. Again, notice that this equation is pretty much guaranteed to be homogeneous because if you see, right, a quick way to notice to check if this equation is homogeneous or not, right? It's a trick that you use in JEE, not your boards, because your boards expect you to provide each step, right? Check each and every coefficient of dy and dx. If the degree of each term is the same. Here it's 2, here it's 1 plus 1 is 2, and here it's 2, right? So basically, it's going to be guaranteed that this equation is homogeneous, right? And you can check this out. This is basically x squared dy equaling minus of xy plus y squared dx. So this is basically dy by dx equaling minus of y by x plus y by x the whole square, right? And this is a function of y by x. So this is going to be a homogeneous equation, right? And so how you solve this? Y equals vx substitution. You basically have v plus x dv by dx equaling minus v squared, right? This is going to become minus 2, right? Therefore, dx by x equals minus dv by v squared plus 2v. We are going to have is an integral on both sides. This is going to give us ln mod x. This you are going to do by partial fractions and is basically going to be minus integral of dv divided by v into v plus 2, right? Which is basically something like a by v plus b by v plus 2 where a plus b equals 1 and 2a, wait, a plus b is 0 and 2a is 1, right? So a is plus half, b is minus half, and what is going to happen is that you're going to have, yeah. So you're basically going to have this is going to give you minus this is plus half ln mod b minus half ln mod b plus 2, right? And this both are going to be this both is going to be equated. So basically 2 ln mod x equals ln mod b minus ln mod b plus 2 plus c. Right? That is going to be the result of your integration. And removing the ln on every side, you're basically going to get x square equals y by x, this is y by x divided by y by x plus 2 times a constant, which I'm going to write on this side, right? So cx square equals y by this, if I just remove this x and rationalize it, this is going to be cx square equals y by y plus 2, right? Or you can basically write this as cx squared y. I made a mistake somewhere. Yeah. So this should be minus, this should be plus, right? And so over here you'll have the 2x, and downstairs you won't have anything. It's just by x. And so this is going to be cx square y equaling y plus 2x, right? Or x square y is c into y plus 2x. Whatever. This c can be on either side, nobody really cares, right? This is a solution to your equation. Cool. 13 being, before going to 13, wait, this is general solution, right? This is general solution. Since again you have the point 1 comma 1, basically substitute that in this equation, you're going to get this is 1, this is going to be 3, and if your c is going to be on this side, you basically have 1 is equal to 3c, and therefore c is equal to 1 by 3, right? Therefore, your particular solution is x per y is equal to 1/3 of y plus 2x, or 3x squared y is equal to y plus 2x, right? That's your answer. Going to question number 13, right? What is 13? 13 is this is x sine squared x by y by x minus y times dx plus x dy equals 0, right? So I'm going to write this simply as minus x dy. This times dx, right? So basically dy by dx is equal to, I'm just going to bring this minus to this side, right? Switching the signs over here, this is going to be y minus x sine squared y by x divided by x, which is basically y by x minus sine squared y by x, right? Since this is a function of y by x, this is homogeneous, right? And so we can basically use the homogeneous rule, y equals bx, and then v plus x dv by dx is equal to v minus sine squared v, right? V cancels out, and then you are finally left with dx by x equaling dv by minus dv by sine squared v, because it's minus over here. And so you basically have ln mod x being equal to, this is dv by sine squared v, basically the integration of cosecant square v dv. And since the differential d by dv d by dx of cot x is minus cosecant square x, right? So you basically have this is basically minus 1 by sine square x, right? So this is basically cosecant v. There's going to be a plus c, right? And there is not much more than this, right? Back substituting b, we basically get ln mod x equals cosecant y by x plus c, over. This is a general solution, right? Since it passes through the point pi by 4, 1 comma pi by 4, since it passes through the point 1 comma pi by 4, what you get here is basically at x equals 1, this is 0, equals cosecant of pi by 4, that's 1, oh wait, that's actually root 2 plus c. Therefore, c is equal to minus root 2, right? Therefore, your particular solution becomes log mod x equals cosecant of pi by x minus, wait, what am I even doing? What am I even doing? What am I even doing? Right? First things first is cot v over here, right? Cot v. So over here again is cot v, right? That means over here cot of pi by 4 is 1. And so c is going to be minus 1. And so over here again, in the result is going to be log mod x equals cot of y by x minus 1, right? Or you can basically say that cot of y by x equals log mod ex, right? Doesn't matter, both are the same, just two different forms of expressing the same message, right? This is the particular solution, right? This is also correct, this is also correct. What form you want to express in the wish? And just make sure that the signs and whatever expression that you have inside are cool. Question number 14. It's y dash minus y by x plus cosecant y by x. CSC is cosecant. I like that shorthand, right? And you have the point 1 plus 0, right? Here is y by x is y by x and is y dash. So basically you can already see that y dash is a function of y by x. This is homogeneous, right? Directly making the substitution y equals dx, or you basically get v plus x dv by dx minus v plus cosecant v equals 0, right? Therefore, basically have dx by x equals minus dv by cosecant v. This is dv by cosecant v, which is basically minus sine v, right? So this integral is going to be minus of minus cos v plus c, which basically means that log mod x is equal to cos of y by x plus c over, right? Since it passes through the point 1 comma 0, that means that 0 is equal to 1 plus c, so c is equal to minus 1. Therefore, log mod x equals cos of y by x minus 1 or cos of y by x equals log mod ex, right? Same as before, both forms are correct. Choose any one form that represents anything, right? That's question number 14. The last question over here, 15. It's 2xy plus y squared minus 2x squared y dash equaling 0 at the point 1 comma 2, right? Over here, what I can see is that degrees 2, degrees 2, degrees 2, this is almost guaranteed to be homogeneous, but you can check, right? Bring y dash over here, y dash is equal to this divided by 2x squared, right? So this is basically y by x plus half of y by x the whole square equals y dash, right? Perfect. And so you basically have the substitution y equals dx. So you have v plus x dv by dx equaling v plus half of v squared, right? This way cancels out. And then you have dv by v squared equals half of dx by x, right? This is minus 1 by v equaling half log mod x plus c. This is basically minus of x by y equaling half ln mod x plus c, right? Or ln mod x plus c equals minus 2x by y. Given that it passes through the point 1, 2, that means that this is 1, this is 2. So minus 1 is basically equal to c. Therefore, your particular solution then becomes minus 2x by y equals ln mod x, right? Or you can basically say that y equals 2x divided by 1 minus ln mod x. This is a particular solution, right? This is a general solution. Same way, over here, this is the general solution. Yes. Same way, this is the general solution. Cool. That's question number 15, right? Finally, coming to the two MCQs. Number 16, the homogeneous differential equation of the form dx by dy equals h of x by y can be solved by making the substitution. I've already done this. The substitution is x equals by, right? Because if you do a substitution of y equals vx, does not matter, it becomes h of 1 by v, which is a headache to solve, right? But making x equals by means that you have an h of v over here, which is easier to solve, much easier to solve, right? And you will have something of the form dx by dy if you differentiate this. This is also pretty easy to substitute over here and solve perfectly, right? Otherwise, over here you will have to do an inverse translation, and then you will have to substitute, and then you have to cross multiply, etc., 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 so on and so forth, which is a headache. It's a big headache. That's why you do C, x equals, right? And 17, which of the following is homogeneous? I've already told you the method to check, right? For each term of dy and dx, check if the power of each term is the same, right? This is 1, this 1, but this is 0. A is not homogeneous, right? This is 2, but this these both are 3, power 3, right? So this is not homogeneous, right? This just by checking this just by, you know, right? Here again, this is of power 3, but this is of power 2, this is of power 2. This is also not homogeneous. Over here, you have y squared, you have x squared, you have 1, 1, that's also 2, this is also y squared. So every term is of degree 2, and so this has the potential to be homogeneous, right? You will notice that whichever function you see in this way has the all parts same. You basically note that they are going to be homogeneous, and I'm going to actually demonstrate it, right? So basically, dy by dx is equal to minus of x squared minus xy minus y squared divided by y squared, right? Wait, it's minus of y squared by x squared minus xy minus y squared, right? Divide this by x squared, divide this by x squared. You basically get y by x the whole squared divided by 1 minus y by x minus y by x the whole square. This is a function of y by x, which means that this is homogeneous, right? So the answer is D, right? Sometimes what happens is you will notice that some equations of this sort may form some kind of a differential equation, like say for example dy by dx equals y by x divided by 1 minus y by x into whole times x cube, right? Sometimes some equations of this sort may occur, right? Then these equations are homogeneous, perfectly homogeneous, right? You have to be very careful in that, right? Because if you see here, just a second. Wait a minute. Yeah, this one, right? So sometimes equations of this form may occur, and they are perfectly homogeneous because they follow this form, right? But you will notice that over here you will not have you will basically have this to be x minus y, and so you will have this x, this So you'll have x minus y times dy equaling x cube y times dx, right? If you check this, you won't have the same power of all terms, but you'll notice that this is x cube times g of other x, right? So for equations of this sort, you have to be very careful because they are pitfalls and they may throw you off your calculations. And be very careful with that. You may notice that none of the A, B, C options are of this form, right? You can how you can check that is basically by dividing the whole thing by x, right? For in A, you have 4 plus 6 y by x plus 5 by x, right? Where everything goes, where you basically know that you get the wrong answer because 5 by x should not be a part of your equation at all, right? Over here, again, it's y dx minus x square into x, x squared plus y square into y by x, right? You have a y square term also. It won't be x power n into g of y by x, but there is also y square term. So again, b is gone. And for c, if again you have to divide by x, and so you'll you have to divide by x squared, and so again you'll be left with a y by x term here, an x term over here, plus 2y by x the whole square, right? And x plus something of this sort. This is reducible to a homogeneous form, but this is not exactly a homogeneous form, right? Right. Thus, we complete exercise 9.5. And I go back to question number 5, where I told you that I'll be telling you what the special property of the circle is all about, right? So basically, this kind of a circle, right? You'll notice that your standard form of the circle is x square, it is x minus a, the whole square, plus y minus b, the whole square, equals r square, if the center is at a comma b and the radius is r. Correct. That's the definition of a circle, right? Mathematically on a graph sheet. So do you have an equation of this form? This basically reduces to x square minus 2ax plus it's a plus y square minus 2by plus a square plus b square minus r square equaling 0, right? That's what this equation reduces down to, correct? And so from this equation, you can determine that the coefficient of x is twice the x coordinate of its center. The coefficient of y is twice the y coordinate of its center. And this expression, the constant term, determines the value of radius after, after subtracting the square of the distance of the center from the origin, right? So basically, from this expression, if you have some kind of a standard form of a circle x square plus y square plus 2gx plus 2fy plus c equaling 0, then g comma f is going to be the center, right? And it's not exactly g comma f, it's minus g comma minus f is going to be your center, and your radius r is going to be equal to square root of it's f squared plus g squared minus c, right? Because this c is going to be a square plus b square minus r square, right? It's going to be basically the c is equal to g squared plus s squared minus r squared. So r square, if it goes on this side, is going to be g square plus s square minus c, and r is going to be root of s square plus g square minus c, right? Remembering these two things, what we have over here is basically g equaling minus c by this is, yeah, g is equal to 2g is equal to c, or g is equal to minus c by 2. right? Because this is going to be x square minus cx plus y square equals 0, right? And if you compare with this equation, 2g is going to be equal to minus c, g is equal to minus c by 2, right? But f is going to be 0. Therefore, radius is going to be square root of, this is going to be c square by 4 minus c, right? Therefore, two properties. Number one is that this equation is going to be the family of circles whose center lie on x-axis, right? And they all have predetermined radius of this form, right? I leave it to you to figure out what exactly this radius is special about, because I'm not really in the mood to figure that out right now. So, but you can basically try to check what exactly is this radius so special for, right? And they have predetermined radius, right? Two things. Those are the two things that I wanted to think about: the center and the radius of the circle. Now we proceed further after exercise 1.5. Finally, we come to linear differential equations, right? What is the linear differential equation? A linear differential equation is an equation of the form dy by dx plus py equals q, right? P and q are functions of x, are functions of x. They are not functions of x and y. They are single variate, univariate functions, right? This differential equation is known as a first order LDE, right? And LDE is a linear differential equation because the order is 1, right? And if you have to be more specific, this is called a first order first degree linear equation. Sometimes you have, first degree is linear. So if you have some function of the sort d square y by dx squared plus p of dy by dx plus qy equals r, this is a second order LDE, right? And this is something that we are not going to be dealing with in NCERT. All right. So just if you think that you need to see what this looks like or what you want to solve, then you may check out this site, right? Wolfram Alpha. Just drop it in Google, you'll get the link. So this is going to be a very good computational website which can solve most differential equations, if not all of them. But for some equations, you'll have to wait a long while and you'll have to get pro membership because, again, capitalism. But we aren't discussing politics, we're discussing math, so let's go back to the topic, right? So what happens here is that you have an LDE and you have a specific way to solve it, right? You have equations of this form, dy by dx plus py equals q, or dx by dy plus px equals q, right? So what you do over here is, first you multiply both sides by a function of x, right? And this function of x is chosen such that the right hand side, right, this right hand side becomes a derivative of y, right? So basically you convert this form and multiply it by some integrating factor. You call it an integrating factor if, right? You multiply it by this a function g of x, right? You multiply it by this function so that this right hand side becomes the integrand of this whole thing, right? If you carry out the derivation, if you carry out the differentiation of the RHS, you have to basically get the LHS. That is a function of this IF, right? And so when you multiply it by this gx, what happens is this inside part, this y into gx, that basically becomes your right? So you can basically see that this is there's a big integration, right? This is a derivation of what you do over here and why you do it, right? And so you basically get the fact that your integrating factor becomes e power integral of p dx, right? And this occurs only when your this thing is a first order linear, right? It's not when it's second order linear. So when you multiply your equation by gx equals e power integral of p dx, the LSS becomes a derivative of some function, and that function that you basically find this function out, right? And so you finally get the value of y equaling e power integral of p dx into integral of q into e power integral p dx plus c. Right? That is the general solution. Right? Look at all these examples because they actually explain what you do and why you do, how you do it. Right? Look at them, solve it out by yourself, get doubts clarified over here, and then you proceed with the exercise. Right? I'm going to directly go to the exercise because I don't want to look at examples. Right? Exercise 9.6. Last before your miscellaneous. Right? Again, you have 19 questions. So for the differential equations in 1 to 12, final simple solution. One is y dash plus 2y equals sin x. Right? First of all, know that p is equal to 2, q is equal to sin x. Right? Your integrating factor if is equal to e power integral of p dx, that is in r e power 2x. Right? So e power 2x dy by dx plus 2y e power 2x equals e power 2x sin x. Right? That is going to be the equation that you are going to solve. Right. So over here, first of all, notice that you can you basically have this. Your solution is going to be y e power 2x is equal to integral of e power 2x sin x dx. Right? Because if you basically differentiate this off, you get differential of y, that's dy by dx into e power 2x plus y into differential of e power 2x, that's 2 e power 2x, equaling differential of this, that's going to be this. Right? Integrating this by parts, what you basically do is let I equals integral of e power 2x sin x dx. Then you have I equaling the first by parts, applying by parts for the first time. You basically get e power 2x into cos x, right? Minus this be a plus 2 times integral of e power 2x cos x dx, right? Because the integral of sin x is minus cos x, right? This is equal to minus e power 2x cos x plus 4 times, plus 2 into e power 2x sin x, right? Minus 4 times integral of e power 2x sin x dx. But this is I, right? Therefore, phi I is equal to, this is 2 e power 2x sin x minus e power 2x cos x dx, cos x, right? Therefore, I is equal to this whole thing divided by 5, right? Therefore, the solution of your equation is y e power 2x equals e power 2x divided by 5 into 2 sin x minus cos x, or y equals 2 sin x minus cos x divided by 5. Of course, you have a c over here. You have a c. Therefore, you will have plus c per minus 2x. Right? You have divided by 2x, and so you'll have plus c per minus 2x. And do not forget the constant. Question number 2. Y dash plus 3y equals e power minus 2x. Right? Integrating factor is e power 3x. And so you'll basically have the equation e power 3x y dash plus 3y e power 3x equaling e power x. Right? Therefore, your general solution is going to be y e power 3x plus c equals integral of, this is e power x dx, which is e power x, right? Therefore, y equals e power minus 2x plus c e power minus 3x. That is your answer for question number 2. Right? Pretty easy, right? This was solved fastly because this became e power minus 2x and the integrating factor was e power 3x. So this cancelled to become e power x, which is easy to get. Most questions are not this easy. I'll just let you in on that secret. Right? Number 3, you have y dash plus 1 by x into y equals x squared. Right? Integrating factor is equal to e power integral of p dx, that is integral of 1 by x dx. This is equal to ln mod x, right? This is e power ln mod x, which is basically x, right? We are constraining x to be positive, and so I'm not bothering with mod, right? Over here, you basically have then that x y dash plus y equals x cubed, right? And so I basically get y, this is xy equals integral of x cubed dx. This is x power 4 divided by 4 plus c, right? Therefore, y equals x cubed divided by 4 plus c by x. That is the solution of it. Right. Question number 4. LDs are actually pretty fast to solve, and because the method is pretty simple and you can easily substitute and go on your own derivative. Right? Is secant xy equals tan x in the first part. Right? And the first part means that both secant x and tan x are always positive. Right? You don't have any stupid what to say discontinuities or sign shifts to actually take care of. Right? So y dash plus secant xy is equal to tan x. Right? Your IF integrating factor is basically e power integral of dx by cos x, which is integral of ln mod tan x plus secant x, right? Which is tan x plus secant x because both are positive, right? So you basically have the solution y into tan x plus secant x equals integral of tan square x dx plus integral of tan x secant x dx, right? This is secant x. This is tan x minus x, right? Plus c. So basically, y into tan x plus secant x equals tan x plus secant x minus x plus c. And that is your required general solution, right? For question number 5, it is cos squared x y dash plus y equals tan x. For an LDE, it should be of the form y dash plus py equals q, right? So divide the whole thing by cos square x is basically y dash plus secant square x into y equals it's tan x into secant square x, right? Your integrating factor IF is equal to e power integral of secant square x dx, that is e power tan x, right? And so you're basically going to have y e power tan x equals integral of e power tan x into tan x into secant square x dx, right? taking tan x as t, you basically see the secant square x dx is dt. And so this is equal to integral of e power t into t dt, right? This is equal to, which you do by parts, basically, and you get out it's e power t into t minus integral of it's minus e power t, right? T e power t minus e power. So basically, plus c, of course. So basically, you have y e power tan x equals e power tan x into tan x minus 1 plus c, or y equals tan x minus 1 plus c e power minus tan x, right? And that is the required solution. Question number 6. One sec. Question number 6. X divided by dx plus 2y equals x square ln x. Right? What to do over here? Again, divide the whole thing by x. And so you have y dash plus 2y by x equals x ln x. Right? Find the integrating factor. It is e power integral of p dx. That's e power 2 ln mod x. That is x square. Right? Therefore, yx square equals integral of x cubed ln x dx. Right? This is integral of ln x times x cubed dx. Right? Integrate by parts. This is integral of what? This is ln x into x4 by 4 minus integral of x cubed by 4 dx, right? Because differential of ln x is 1 by x. This is x power 4 ln x by 4 minus this is x power 4 by 16 plus c, right? That is yx squared. Therefore, y is equal to, is an x square, is an x square, this is x minus 2. Therefore, y equals x square into ln x by 4 minus 1 by 16 plus c by x square, right? And that is the required solution. That is question number 6. Question number 7, right? X ln x y dash plus y equals 2 by x ln x, right? Divide the whole thing by x ln x. This is y by x ln x. This will be 2 by x square. This ln x gets out. So basically, you will have your integrating factor if equals e power integral of dx by x ln x. This is equal to ln x, right? Because integral of dx by x ln x is ln of ln x, right? And so you'll basically have an equation like y dash ln x plus y by x equals 2 by x squared ln x, right? So y ln x is equal to integral of 2 ln x dx by x squared. Now this is equal to, if you take 1 by x as t, no, if you take ln x as t, it's 1 by x as t, right? By x as t. So basically integrate by parts again. So it's 2 times whole of ln x into x power minus 2 dx. That is ln x into minus 1 by x plus integral of 1 by x squared dx, which is 2 into minus ln x by x minus 1 by x plus c, right? So you basically have y ln x equals y ln x plus 2 ln x by x plus 2 by x equaling a constant c. Therefore, divide the whole thing by ln x, basically get c by ln x, right? And so y plus 2 by x plus 2 by x ln x equals c by ln x. That's a representation, right? Question number 8. 1 plus x squared times dy plus 2xy dx 1 plus x squared dy plus 2xy dx is equal to cot x dx, right? Again, bring this to standard form. This goes to the other side as minus 2xy dx and bring dx downstairs, 1 plus x squared downstairs. You basically get dy by dx is equal to cot x by 1 plus x squared minus 2x by 1 plus x squared, right? Bring this over here, then you will basically have this form of an equation like y dash plus 2x by 1 plus x squared into y is equal to cot x by 1 plus x squared, right? So the integrating factor if is going to be equal to e power integral of this, which is basically e power ln of 1 plus x squared, which is basically 1 plus x squared, right? So multiplying this whole equation by 1 plus x squared, you get something like this becomes 1 plus x squared y dash plus 2xy equaling cot x, right? Which is your original equation if you see over here. But I've just collected all the dx terms over here, right? And so you basically have the solution. Y into 1 plus x squared equals integral of cot x dx, right? Which is basically epsilon naught sin x plus c sin x, right? Therefore, y equals ln mod sin x by 1 plus x squared plus c by 1 plus x squared, right? That's question number 8. Question number 9. xy dash plus y minus x plus xy cot x, right? This can be rewritten as xy dash plus y into 1 plus x cot x equals x. This is 1 by x, this x goes off, you have a 1, right? So this whole thing is p, this is q, right? And so your integrating factor is basically e power integral of this, which is e to the power of ln mod x plus integral cot x is ln mod sin x, right? Which is basically x sin x, right? And so you have y into x sin x equals integral of x sin x dx, right? This is done by partial fractions. No, this is done by integration by parts, not partial fractions, sorry. Where you take it as x into minus cos x plus integral of cos x dx, which is basically sin x minus x cos x plus c, right? So basically, just a minute, I'll just cross check. It's cos x minus cos x plus x sin x. Yeah, of course. Therefore, y into x, right? This is x by sin x equals sin x minus x cos x plus c. This is a valid form. You want to separate y out. This basically becomes 1 by x minus cot x, right, plus c cosecant x by x. This is also a valid form, right? Question number 10. 10 is pretty simple. It's y dash plus 0 is 1 by x plus y, right? Which you have to actually think of this a little bit, because this cannot be a valid, cannot be a valid form for any linear equation, right? What you can do, what you can do otherwise is basically take a dx by dy equals x plus y, right? For dx by dy, remember that differential form is dx by dy plus px equals q, right? There it was dy by dx plus py equals q. All right. So now this. Therefore, this is dx by dy minus x equals y, right? Your p is 1 minus 1 and your q is 5, right? Therefore, your integrating factor if is going to be equal to e power minus x, and your solution is going to be e power minus y, I'm sorry. And so your solution is going to be x e power minus y equals integral of e power minus y into y dy, which is basically, again, integration by parts over here. And so you have y into e power minus y in a negative plus minus e power minus y, right? Because it's plus integral of 1 into e power minus y, that's minus e power minus y, right? And this goes off everywhere and you're left with a c e power y. Therefore, x equals minus y minus 1 plus c e power y, right? Or c e power y equals x plus y plus 1. This is the record. All right. That's question number 10. Question number 11. Y dx plus x minus y square dy, right? This, what we'll be doing is, again, make this linear. And for that, we'll be dealing with, over here we have a y dx, but we have an x minus y square term. So again, we'll be comparing with dx by dy plus px equals q, right? Because over here you see that you have this y square term multiplied with dy, right? If there was an x square term with dx, then we'll take dy by dx, but here we'll take dx, right? So to take dx by dy, what we do is you basically do y dx by dy plus x equals y squared, right? Divide by y, divide by y, and so you have p equals 1 by y, q equals y, right? So your integrating factor is going to be equal to y, right? So therefore, this is going to be y into x dash plus x equals y squared, right? Therefore, xy equals integral of y squared dy. This equals y cubed by 3 plus c, right? Therefore, your solution is x equals y squared by 3 plus c by y. Good. That takes care of question number 11. And question number 12. Fine. 12 is x
hello,
plus. Yes, sir.
एक छोटा सा रिक्वेस्ट सर, आई स्मॉल रिक्वेस्ट, बिकॉज 4:30 पे अनदर सेशन हमारा एक लगा हुआ है सेम आईडी पर,
ठीक है सर। तो
अब मैं चाह रहा था कि 4:30 तक जितना हो जाता है उतना इसको कर लेते हैं, देन
हाँ सर, हाँ सर,
बाकी का
श्योर।
जो बैलेंस रेस्ट रह जाएगा ना, उसको
हाँ
फिर हम लोग नेक्स्ट सेशन में करेंगे।
हाँ सर, तो 4:15 4:20 तक
फोर ट्वेंटी
मैं,
फाइव तक यू
हाँ
हैव टाइम,
4:25 तक।
4:25।
ठीक है, ठीक है सर।
ओके,
धन्यवाद।
थैंक यू।
All right. Resuming in 5, 4, 3, 2, 1. All right. So question number 12. You have x plus 3y squared into y dash equals 5. Right? So again, your same old linear differential form. Right? Since you have a y dash over here, but you have an x plus 3y squared term. Right? What you do is, again bring it to the dx by dy form because that is going to be easy to manage. Right? So bring this y back. You have an x by y plus 3y equaling dx by dy, right? And so dx by dy minus x by y equals 3y is a differential form, right? From this, you basically get that p is minus 1 by y, q is equal to 3y. And so your integrating factor if is equal to e power ln mod y minus, which is equal to 1 by y, right? And so you basically have x by y is equal to integral of 3 dy, that is equal to 3y plus c. So x is equal to 3y square plus c times y, and that is your solution. Correct? Right. And we proceed to question number 13. In 13, we need a particular solution satisfying the given condition, right? As usual, as we have done in the previous exercises. So in 13, we have this y dash plus 2y tan x equals sin x. And the point pi by 3 comma 0. Right. Simple. Over here we have your integrating factor. This is directly in your standard linear LE form. So integrating factor is equal to e power integral of 2 integral of tan x dx. That is secant square x, right? So basically, what you're going to do is y into secant square x equals integral of sin x by cos x into cos x, right? Sin x into secant square x dx, right? This is integral of tan x secant x dx. Because secant square x is 1 by, this is secant square x is equal to secant x divided by cos x, right? Because secant x is 1 by cos x. So basically, this 1 by cos x have taken it in conjunction with sin x to give tan x, and have rewritten this as tan x secant x dx, which is basically secant x plus c, right? We have y secant square x equals secant x plus c as a solution, right? Or y equals it's cos x plus c times cos square x, right? Whatever. And then you have the point pi by 3 comma 0. At pi by 3, cos of pi by 3 is half. Half plus c by 4 is equal to 0. So c is equal to minus 2. Therefore, y equals cos x minus 2 cos square x. That is your particular, right? That's question 30. Going to question number 14. 14 says that 1 plus x squared y dash plus 2xy equals 1 by 1 plus x squared. And the point 1 comma 0. Right? Over here, we have this divided by 1 plus x squared. This is in your standard LE form. Basically, this becomes your P. This becomes your Q. And so your integrating factor IF is equal to e power integral of P dx. That's equal to this whole thing's integral. This integrates to form ln mod 1 plus x square. And e power ln mod 1 plus x square is basically 1 plus x square. Right? And so the solution is going to be y into 1 plus x squared equals integral of 1 by 1 plus x squared dx, which is basically tan inverse x plus c. Right? Since we have the point 1 comma 0, substitute that in this equation, you basically get y into 1 plus 0, right, is equal to tan inverse 0 is also 0, is equal to c. Right? Since y is 0 over here, this implies c is equal to 0. Right? Instead of y, I can basically write 0. Wait a minute. This is tan inverse 1. So it's c plus pi by 4. I'm sorry. So c is not 0, c is minus pi by 4. Therefore, you basically have y into 1 plus x squared is equal to tan inverse x minus pi by 4. And that is a particular thing. Right? Question number 15. Say y dash minus 3y cot x is sine 2x. And you have the point pi by 2 comma 2. Over here, again, basically have this. You basically have this. You have 3 cot x times y. Right? So 3 cot x is your p. Sine 2x is your q. Therefore, you basically have your if to be e power whatever the integration of cot x is to the power of e, the whole cube. Right? Basically, this forms your integrating factor being 1 by sine cube x. Right? Because it is there is also a minus over here. It's basically e power minus 3 integral cot x dx, that is e power minus 3 ln mod sin x, which is basically sin x power minus 3. Right? And that is 1 by sin cube. Therefore, you have your solution to be y by sin cube x equals integral of sin 2x, that is 2 sin x cos x dx by sin cube x. There is one sin gone, this becomes sin square x. Since this is cos x, you can basically take this as t, sin x as t. This whole thing will be dt. And basically, you will be dealing with integration of twice the integration of dt by t squared, that is minus 2 by t. Right? And since t is sin x, this is basically minus 2 by sin x plus c. So you basically have y is equal to minus 2 sin squared x plus c sin cube x. This is the general solution, right? This is your general solution. Since you have the point pi by 2 comma 2, over here, you substitute pi by 2, sin of pi by 2 is 1. So basically you get the fact that c minus 2 is equal to 2, and so c is equal to 4. Therefore, the particular solution is y equals 4 sin cube x minus 2 sin squared x. That is question number 15 done. Question number 16 is find the equation of a curve passing through the origin given that the slope of the tangent, that is dy by dx to the curve, is equal to sum of the coordinates of the point. So basically, We can rewrite this as dy by dx minus y equals x, right? Your p is equal to -1, q is equal to x. And so integrating factor is basically equal to e power minus x, right? Therefore, your solution is y e power minus x equals integral of e power minus x into x dx. This is basically you integrate by parts over here and you basically get x times e power minus x e power minus x minus e power minus x plus c, right? Therefore, y is equal to minus x minus 1 plus c e power x, right? C e power x is equal to y plus x plus 1. That is the answer, right? Since your curve, this is a family of curves, right? They have asked you the equation of a single curve passing through the origin. That means that 0, 0 satisfies this curve, right? If 0, 0 satisfies this, basically that means that c is equal to 1 because e power 0 is 1, 0, 0, 0 plus 0 plus 1 is 1. So c is 1, right? Therefore, the particular solution, that is the curve, is e power x equals y plus x plus 1. Cool? That is question number 16. Question number 17. 17 states that your sum of the coordinates of any point exceeds the magnitude of the slope of the tangent by 5, right? Which means that y dash minus y is equal to x minus 5, right? So your integrating factor again is e power minus x, but the solution becomes y e power minus x equals integral of e power minus x into x dx minus phi integral of e power minus x, right? Which is basically e power minus x into x plus 1 plus phi e power minus x plus c, right? Therefore, y is equal to minus x minus 1 plus 5 plus c e power x, right? This is plus 4. So basically, c e power x is equal to y plus x minus 4. This is a family of curves. Again, since your point is 0, 2, substitute 0, 2 over here. This is basically 2 minus 4 is minus 2. So c is minus 2. And therefore, you have minus 2 e power x equals y plus x minus 4. Or you have y plus x is 4 minus 2 e power x. That is the curve asked for, right? 18. The integrating factor of the differential equation, this is basically write this as your in the standard form. That's basically y dash minus y by x equals to x, right? Your integrating factor then becomes e power integral of minus x inverse dx, right? Which is basically e power ln mod 1 by x, which is 1 by x, right? Actually mod of 1 by x, but see the answer. Finally, the integrating factor of the differential equation, this is, right? For question number 19 on the other hand, so you have 1 minus y squared into y dash plus yx equals ay and minus 1 is less than y is less than, okay, fine. So we have basically written this to the standard form. Since they only asked for the integrating factor, we don't really need to care about this, right? The integrating factor is going to be if is e power integral of p dx, that is y dy. Wait, yeah. Problem here is that this is y dash, but you have y by 1 minus y squared, and you should have y, right? Since this is an equation in x, right? We may try to rewrite this whole thing. This is dx by dy. So that simplifies matters a lot. This is dx by dy. right? We're going to see that. So basically what we can do is IF is equal to integral e power integral p dx over here. Oh no, this p dy over here. That's y dy divided by 1 minus y squared, right? This is basically e to the power half of ln mod. This is minus half, right? It's minus half ln mod 1 minus y squared. This is 1 by square root 1 minus y squared, right? Therefore, d is the integrating factor, right? With that, we complete exercise 9.6. Thank you for listening. Have a nice day.